In this video, we will be discussing about total differential. So previously, um, the concept behind this was about the previous lesson. So it's about partial derivatives. So using total differential, you can solve. I can't really explain it generally. It's easier if I explain it using a sample problem, um, which I will be citing later. So essentially, for total differential, you are given z is equal to f of xy, and if delta x and delta y are increments. So this is an important term, increments. Increments of x and y respectively. So then the differential of x and y are the following. So we have dx is equal to delta x is equal to x2 minus x1. In the same way, dy is equal to delta y is equal to y2 minus y1. So the total differential of z is expressed as dz is equal to partial z over partial x times dx plus partial z over partial y times dy. So how do we apply that in a sample problem? Let me show you. So for the first sample question, we have z is equal to x squared y cubed plus x over y. So how do we find the total differential? So essentially, based on this formula, we have to look for two things. We need to solve for partial z over partial x and partial z over partial y. So that's what we're going to do. So partial z over partial x, we're going to render y as a constant. So product rule, 2x times y cubed plus x squared times derivative of y cubed is 0. And then we apply quotient rule in this fraction. Or I think the better idea is, since y is a constant, we can rewrite the fraction as 1 over y times x. We're going to set aside the constant basically. And the derivative of x is going to be 1. So simplify to xy cubed plus 1 over y. Okay, so this is our partial z over partial x. How about our partial z over partial y? So x is going to be a constant. So derivative of x squared is going to be 0. Copy y cubed plus x squared times 3y squared plus, okay, at this point, since x is the constant in this fraction, I think so far what I only know to do is quotient rule. So it doesn't really matter, I believe, at least from my experience in other problems, even if there's a constant. And even in this case, my first instinct was to say apply quotient rule. It works, but this one is a faster method, just separating the constant from the variable. But here, I don't think we can separate anything, so we just apply quotient rule. Derivative of x is going to be 0. X times derivative of y is 1 over y squared. 3x squared y squared plus minus x over y squared. So that's it. Now we substitute in the actual formula. So dz is equal to 2xy cubed plus 1 over y times dx plus 3x squared y squared minus x over y squared times dy. So that's it. Yeah, that's it. By the way, just to let you know, dz could also be rewritten as z2 minus z1. So yeah, but essentially this is the final answer for the given question. So what else? Let's compare total differentials and differentials of multiple variables. What's the difference when we try to solve? Let me see first if I can provide a proper example to compare the difference of the two. If I can't, then we'll just move on to more practice questions. Okay, let me just show you my solution. Again, we are comparing total differentials and the method shown in differentials of multiple variables, or DMV. So given the example z is equal to x squared times square root of xy minus y squared, we are tasked to find dz using both methods. But I don't think I'm going to show you the entire the complete solution for each method. Using total differentials, let me rewrite first the formula so it's easier to visualize. So using total differentials, I'll be solving for partial z over partial x. And okay, that's it for now. So we're gonna consider y as a constant. We could rewrite the example as x squared times xy raised to 1 over 2 minus y squared. Okay, we're gonna apply product rule. So 2x times xy raised to 1 half plus x squared times 1 half xy raised to negative 1 half, and then product rule x. Actually, we don't need to use product rule. Y is a constant, we set it aside. Derivative of x is just 1, so just y. And then y is a constant, right? So y squared is going to be 0. So that's it. Simplify. 2x square root xy plus x squared y over square root xy. At this point, we can rationalize. So 2 times xy. Multiplying these two makes them squared, so you can basically remove the radical sign at that point. Okay. Factor something from the numerator. xy. Wait a minute. I think I'm missing something. I am. A 2. I think the solution's a little confusing. Um, we can rationalize at a later time. Let's find the LCD first. Then rationalize. For, oh wait, we can add these together. So we have 5x squared y times square root of xy to xy. We can cancel something. Cancel, 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 cancel. 5x square root of xy over 2. Okay. So that's how you solve using total differentials. How about using differentials of multiple variables? Just a disclaimer, I'm not really sure how to solve this anymore. I'm just copying the solution at this point for DMV. So coming from the given, so x squared, x raised to 1/2, y raised to 1/2. These come from the square root, okay, and minus y squared. Basically, you convert any term that's in radical form into exponential form, and try to simplify by, for 1, you combine these two. So 4 over 2 plus 1 over 2, 5 over 2. And then just copy the rest for now. And then, what do you do? So apparently you factor y raised to 1/2, and y squared becomes 0. So you end up with, oh wait. Huh, that's weird. It becomes raised to 3 over 2. I can't really explain much on that. Okay. So essentially, they're the same thing. Let's continue. This time we'll be finding partial z over partial y. So it's we already found this. Now that one. So let's copy this below. So we're going to render x as a constant. power rule. So 1/2 times xy raised to negative 1/2 times 0 times y plus x times 1 minus 2y. X cubed over 2 square root of xy minus 2y. LCD. Rationalize. We don't need the 2. So x cubed square root xy minus 4y times xy over 2 times xy. I don't think there's anything that we can cancel. I think that's it. Wait. I think we can cancel something. X cubed square root xy 4xy squared over 2xy. If we separate, it is clear that we can make this like that, and at the right side 2y. Okay, so this is a more simplified version for partial z over partial y. So that's how you solve using total differentials. How about using differentials of multiple variables? So x squared x raised to 1/2 y raised to 1/2 minus y squared, and then combine the x's. So 5 over 2 y raised to okay. At the same time, you derive any variable that's y. So y raised to 1/2 becomes 1/2 y raised to negative 1/2 times 1 minus 2y. Okay, and then at this point you can see that our solution is similar to the answer we found using TD. So you don't have to find LCD at this point, just rationalize. So square root of y, square root of y. What you'll get is x raised to 5 over 2 square root of y over 2y minus 2y. Do we have a similar okay, wait, we can turn this further into x raised to 5 and then 2, right? x to x to x. X squared square root of x square root of y. Now at this point, does the solution look familiar? It does. So x squared xy square root of xy, you can merge these together, and so you have essentially the same thing. Now let's combine. So dz is equal to partial z over partial x, which happens to be this or this. Let's choose this. Partial z over partial x times dx plus partial z over partial y times dy. This is the final answer. Okay, so let's have a few more practice questions. Oh, this is fun. Actually, I wanna start on this already. Let's do this practice question. So we have f is equal to u v w squared plus x ln y minus u x z over y. We are tasked to find what df is. So this is quite pretty new notation to you, but only just what you just have to know is that in the context of total differentials, since the variable here is f, we're tasked to look for df. Df is basically this. So what are all the variables that we are dealing with right now? U, v, w, x, y, and z. Right? So coming from this formula, how do we modify it in the context of what we're given? So we're basically going to write something like this for every variable. So let me show you. df is equal to partial f over partial u times du plus partial f over, what's the next letter in the alphabet chronologically, u w and then x and then y and z, right? So far, if ever you've noticed a pattern, that's how you actually write the formula for total differentials. Since the variable that we have in the left side is, in this case it's z, so z is always going to be in the numerator. And since what our variable is f right now, f is going to be in the numerator. And the variable in the denominator, so in this case partial u, the d beside it is also going to be beside the same variable. So partial u du, partial w dw, partial x dx, partial y dy, partial z dz. Okay, so this is essentially what we have to find. It looks long, but based on what we're given, it's relatively easy. Let me show you. So first we have to look for partial f over partial u. In that case, any variable here that's not mentioned is technically considered a constant. So anything that's not u, okay? In other words, w, x, y, and z are all going to be constants. Okay, so that makes it easy to differentiate, because you're just going to treat all the other variables as a constant. So in that case, what are the constants here? W. What else? Wait a minute. We also have the variable v, right? We didn't write it in the formula. Wait a minute. U, W, U, V, T, U, V, W, X, Y, and Z. T, U, V. So between W and U, we have V. Okay? So U, V, W. 4 variables are considered constants. So essentially, set aside V and W because both of them are constants. Derivative of U is going to be 1. We good so far? So constant X and Y are constants, right? So don't bother. This entire thing is going to be 0. And then, what else? One over Y. X and Z are also constants. So X, Z over Y separated from U. The derivative of U is going to be 1. So further simplify. This is what partial W over partial U is going to be. Next, partial F over partial V. Let's look for that. In that case, U, W, X, Y, Z are all constants. So V, U, and W are constants. Derivative of V is 1. Plus, X and Y are all constants again. So this one is going to be 0. Minus U, Z over Y. Actually, U, X, Z, and Y, they're all constants. So this is also going to be 0. That's it. U, W squared. That is our partial F over partial W. I hope at this point you're grasping a certain pattern. This time, the third one, partial F over partial W. U, V, X, Y, Z are all constants this time. So W squared. Oh wait. U, V are constants. W squared becomes 2W. X and Y are still constants, so 0. U, X, Z over Y is gonna be 0. There's no W in it. So 2U, V, W. That's it for partial F over partial W. Next, partial F over partial X. Yep. So U, V, W, Y, Z are all going to be constants. Everything except X. So 0, this becomes 0. X, okay, put aside L and Y. Derivative of X is gonna be 1. Minus, set aside U, Z over Y. Derivative of X is gonna be 1. Simplify, L and Y minus U, Z over Y. So that's gonna be the answer for partial F over partial X. How about partial F over partial Y? U, V, W, X, Z. These are all constants. So Y, this becomes 0. first term. Set aside x. Derivative of ln y is 1 over y times derivative of y, which is 1. Minus, okay, everything is a constant except 1 over y. We can rewrite 1 over y as y raised to negative 1. And if we find the derivative of that, this becomes positive. Negative 2 times 1. Okay, I think that's it. Simplify x over y plus uxz over y squared. So this could be the answer already. If you want to merge the two fractions, you can. It's technically not prohibited. Okay. Partial f over partial y. Partial f over partial z. U, v, w, x, y are all constants. Zero plus 0 minus ux over y times z. Derivative of z is just 1. So the answer is going to be negative ux over y. That's it. So, are we done? I believe so. Using all of these values, we just put them in one expression. So, yeah, just combine. Substitute. So, vw squared minus xz over y, and then times du, plus partial f over partial v is uw squared, partial f over partial w is 2 uvw, times dy minus ux over y times dz. Let's rewrite this here. Okay. Yeah, this is the final answer.